Hi guys, myself Manoj.M. In this video, we are going to solve this practice problem 3.4. Find V1, V2 and V3 in the circuit of figure 3.14 using nodal analysis. Yeah, right. Yeah, let us solve this problem. The current here goes in this way and here in this way and here in this way. Okay. Let us apply super node to it. Okay. Yeah guys, let us write the circuit after we apply the supernode here. This one is the 6 ohm from V1 to V3, right? Yeah. Right, 6 ohm here and here V is equal to 0 because it is grounded, right? Yeah, then this one is 2 ohm, this one is I, right? And this one is 4 ohm and this one is 3 ohm, right? Yeah. Then from connect here to here and then switch this to ground V is equal to 0, right? Yeah. Guys, yeah, we first apply KCL at supernode, okay? Apply KCL at supernode, yeah. We know that the KCL states that the sum of current entering the node is equal to the sum of current leaving the node. Okay. Here to the supernode, can see that this current is entering here, but it is also leaving here. So these cancel each other, and these three currents are leaving. Okay. The input current that will be 0 and the output current that will be V1 minus 0 by 2. That will become V1 by 2 and then V2 minus 0 by 4, that is V2 by 4, and then V3 minus 0 by 3, that means V3 by 3. Okay. Yeah, we need to make this denominator as 1. For that, multiply it by 12. Okay. Yeah, after it will be equal to 2 6 are 12, 6 V1 plus 3 V2 and then plus 4 V3 is equal to 0. That will become equation 1. Okay. Yeah, then I will put a line. We need another two equation to find V1, V2 and V3. Okay. Yeah. We know that V1 minus V2 is equal to 25 volt, right? Yeah. Here, right, at the 25 volt voltage source. Okay. V1 minus V2 is equal to 25. Let us consider this as equation 2. And yeah, this one is the current controlled voltage source. Here it is V3 minus V2 is equal to 5I. Okay, yeah. Let us write that one also at the dependent source. V3 minus V2 is equal to 5I. Yeah, we need to find what is I from the circuit. I is equal to V1 minus 0 by 2, that is V1 by 2. Okay, yeah. Here, right, V3 minus V2 is equal to 5 into V1 by 2. Yeah, right, I will put line here this side. Here it will become 2V3 minus 2V2 is equal to 5V1. Okay, I will move this to this side. Okay, 5V1 plus 2V2 minus 2V3 is equal to 0 volt. Okay, yeah, let us write the three equations here. Okay. Yeah, here it is there. Again, I will also write it here. Okay. 6v1 plus 3v2 plus 4v3 is equal to 0. Okay. And then second equation is v1 minus v2 is equal to 25. Okay. v1 minus v2 plus 0 v3 is equal to 25, and then 5v1 plus 2v2 minus 2v3 is equal to 0. This one is equation 1, this one is equation 2, and this one is equation 3, right? Yeah. Okay, let us solve this equation. Okay, we'll open the calculator. Here, click on mode setup, then click on equation. That means the phi it is in the form of anx plus bny plus enz is equal to dn. Then click on 2 and then click on 6. Okay, equals to 3 equals 4 equals 0. Okay. 1 equals to minus 1, 0, and then 25. Okay. Here it is 5, then 2, then minus 2, then 0 equals to, yeah, V1 is 7.608 volt. Okay. Yeah, right. I will slightly move this above up. V1 is equal to 7.608 volt. Okay. And then I will open the calculator again. Click on equals. It will become minus 17.39. Okay. That means V2 is equal to minus 17.39 volt. Okay. And then I will open the calculator and then click on equal. Here V3 is equal to 1.6304 volt. Okay. V3 is equal to 1.6304 volt. I will put a box to this. I hope you understand how I solve this problem. If you have any doubt, you can comment in the comment section. If you didn't subscribe my channel, please subscribe my channel and hit the bell icon. Thank you for watching, guys. This one is equation 3. I didn't mention it. Sorry. Okay, I will slightly move this from full top to bottom. Okay. Yeah, right. I hope this video helped you. Please hit the like button. Please subscribe and share with your friends. That's it, guys. Thank you for watching.